Hello everybody, this is Steve here, and today we are, I am giving a little bit of an, introduction to this here, video. So yeah, today we are doing a video of, stuff. And, well, I suppose technically it's not me that's doing the video, but I am doing an introduction to the video, so I am doing part of the video, so whatever. But my name is Steve. Hello. My name is Steve. Hello, hello, hi, hello, hello, hi, hi, hello, hi, hello, hi. But yes. So this video is not a Minecraft video. This is a new series that Handy Andy is thinking of doing occasionally. It is a I think he said he was going to call it random stuff with Handy Andy. Yes, yes, yes. I believe that was correct. But anyways, so that will be very interesting. And yes, I have been talking all over the place, and yes, and yes, and yes, and yes, and like that, And so I think I'm going to be handing it over to Handy Andy, because I'm handing it to Handy Andy and everything, and it's fun. And I will see you later. So yes, goodbye. Hello everybody, this is Handy Andy here, and today I'm gonna be talking about the Rubik's Cube. Now, the Rubik's Cube is a cube made by Rubik's. I think so, which is why it's called the Rubik's Cube. And the Rubik's Cube is a cube where you flip the sides and you can do weird, if you flip them straight, you can do weird things with it, and you can get weird combinations, and then you have to solve it all back and get it all back to normal and everything, and it's really weird, and it can be kind of hard if you don't know how it works and everything like that. And I think I've got it completely messed up right now. So I will take a second and solve this back to normal, and I will be right back. Now, where are those pieces? One there. Hello. There we are. And I don't know if I'm going to include the singing in the recording, but that's just, in case you're wondering, that's just something I made up just then. I wasn't actually singing a song that I've known, although it might have resemblances to songs that I've heard, but whatever. We're not here to talk about music.
we're here to talk about the Rubik's Cube. This time, at least. So, the Rubik's Cube, I already said that. Where were we? Hang on a second. Just give me a second to remember where we were at, because I completely forgot it while I was resolving the cube. So, yeah. Haha. Alright, so in this video, I'm going to be talking about some stuff about how the algorithms work. What I've learned just from, I don't know, just an idea that I got that seems to work. I haven't actually done any research into how it works. The only research I've really done is how to actually solve it. Okay, my computer just shut off, so it's quiet now. Yes. So I'm going to be talking a little bit about how the algorithms work. So the most common algorithm, at least to my knowledge, is right inverted, down inverted, right, down. Which, if you do it 6 times, the cube will turn back to normal. So that was 1, 2, 3, 4, 5, 6. Alright, so it took 6 times. And actually, let me just see if I have it on this sheet of paper. No, I do not. So I will just explain it just from my, in my head. Well, actually, I will not explain it in my head. I will explain it out loud, because if I was explaining it in my head, you wouldn't be able to hear it. So it wouldn't be very useful in that case. But what ends up happening, if you do the algorithm once, like the question that the question is, why does it take 6 times of doing it to go back to normal? Why doesn't it take 7 or 350 or 10,000 and whatever? Well, if you do it 1 time, then, well, first we should figure out which pieces actually move. And if you do it 1 time, you can tell that, because after once, the pieces that are still in the same place are the pieces that didn't actually change position. So it's just this little snake down here that actually moved. So if you do it once, all of these are out of position. If you do it again, then they're still all out of position. If you do it again, this one, and this one, and this one are in the right place. Which means that, which is after 3 times. So after 3 times, all these go in place. Now you have to remember that 3. Now, you do it 4. Now they're all out of place. 5. They are all out of place. 6. Now, the corners have gotten back in place. And so, it takes 3 times for the edges and 6 times for the corners. And the least common multiple of 3 and 6 is 6, which is why it takes 6 times for the whole thing to get back to normal. Now that was a little bit hard to see on that algorithm, just because it all happened all at the same time. But if you do some other algorithm, like, for instance, I didn't actually do that one yet. For instance, this one, which is right invert, this top one, by the way, there's supposed to be a line in between this. So this top one. So that is right inverted, right down, rotate, 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 and now you're back to the original rotation, and that is 1 time of doing the algorithm. And it turns out this one takes 9 times, because most of the edges, actually in this case all the edges, come back to normal after 3 times. and most of the corners, all of the corners in this case, come back after 9 times, which means that it takes 9 times of the algorithm to get back to normal, because that's the least common multiple. Now, I won't demonstrate that right now, just because it's a little bit complicated to keep track of the algorithm, like I just did. I will be back in a second when I resolve the cube. My singing is not on key very well, very good, very perfectly thing. But I will keep on singing just because it's fun, and I will sing while I am solving a cube. Sing, 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 flip, 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 sing, 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 and solve the cube. And then we will get the second layer into place while we're getting the first layer, finishing getting it into place. And I'm repeating my sentence in mid-sentence, and it's very weird, and I'm just going to continue, and I will stop singing. I will stop singing words. I will just start singing with non-words. And the song sounds very much like something else that I've heard, but I don't know what it is. Actually, it sounds like a very lot of things that I have heard before, but I will finish this cube, and I will spin and spin and get spin and spin and get confused, and I will run out of words to say. Da-doo-doo-doo. Let's change the style. Let's change the style of the music. The music, music, music. Singing, 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 singing. Singing, 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 singing. We're singing as we're flipping the cube around, and it's taking a very long time, and I'm going to continue flipping and singing and flipping and singing and flipping and singing it. This is probably getting over and over and over and over again at the same tune. Da 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 da. I'm flipping and flipping and flipping and I wonder if I can actually do a tune of the algorithms. So this is one that you sometimes use, but not always you will use, which is right, up, right inverted, up, right, up, right inverted. And then the cube is in the right place, except for the corners. The corners are not in the right place, except for this one, but it is flipped the wrong way. And so we need to hold it over here and go up, right, up, away, up and right away, up, towards, up and right towards. And then we will get the rest in the place they're supposed to be, except we need to do it again because it didn't work the first time. And so then they are in the right place, and then we flip the cube, flip the flip. That was the wrong direction. The flip the flip 8 more times. 3, 4, 5, 6, 7, 8. The cube. Alright. Now, I have no clue where we were just at. Yes, we were doing this. Yes, so it equals out to 9 times. And yes, so what we were going to try is an interesting one. Right inverted, left inverted, down inverted, up. Which actually sounds kind of cool. Right inverted, left inverted, down inverted, up. Right inverted, left inverted, down inverted, up. Like that, you know. Yes, so, which is right inverted, left inverted, and then down inverted, up. So it's kind of cool. Now, that one, I've already worked out some of it, except that I think I got mixed up as I was going. So I'll be more careful this time. So right inverted, left inverted, down inverted, up. And there are no pieces in the right place. And you can tell that quickly and easily because the sides of the top layer and the sides of the bottom layer are connected to the top sides of them and the bottom sides of them. So we just need to check the top face. There's 2 weight, but they're not the same on the side. So like we can already skip those pieces just like that. And same thing on the bottom. And then we can do the same thing for the edges here, and they are not in the right place. So that was once. And actually, just to not be confused, I'm gonna mark it down. So that's once. All right. Right inverted, left inverted, down inverted, up. And there is nothing in the right place. So, right inverted, left inverted, down inverted, up. And that was 2 actually last time. This is 3 this time. Now, this and this are white, but they are not in the right place on the other side. And this, on the 3rd time, the red, yellow, and blue piece is in the right place. So that's 3, not 6. And the yellow, orange, and green piece, or the yellow, orange, and green piece, depending what you'd like to call it, takes 3 times to get back to normal. Alright, now is there anything else? There's those on the bottom, there's those on the top, and on the edges there is nothing. So, that was 3 times. Now, right inverted, left inverted, down inverted, up, that's 4. And there is nothing there, nothing there, nothing here, and nothing here, so there's nothing. So, 5. And there is nothing here, nothing here, nothing here, nothing here. Alright. 6. And this. So after 6 times, there is a kajillion pieces back in the right place. Namely, this one, this one, this one, this one, this one, this one, this one. So basically, all the ones around the edge, all the edge pieces basically are all back in the right place. And the corners, there is this one and this one, and this one and this one. So that is these ones. And so, if we continue going, because we're still unaccounted for of these ones, and these ones. So that was 6 times, and I forgot to mark it down. I'm trying to do this to keep track, and I'm forgetting to mark it down. Alright. This is 7. 7. Now, all we need to check at this point is these and these, which would be these and these, and none of those are in the right place. So that's 7, 8, and nope, 9. I better mark that down. And nope, 10. I hope I didn't miss it along the way. No, nothing. Actually, an easier thing to check is just check if any of the corners are the right color. And then I can check the sides if they're the right corner that I'm looking for. So that was 10, 11, and nothing. 12. So after 12 times, these come into place. Alright, so now we need to take the least common multiple of, OF is an abbreviation for of, just in case you were wondering. And of, in case you were wondering, would technically be spelled U-V-V-E. Of. Or actually, you could erase the E. So just of. And OF is an abbreviation for of. There. That be's good grammar for you. Yes. So, least common multiple of, 3, 6, and 12, in this case, happens to be 12, because 3 and 3 is 6, 6 and 6 is 12, so 12. So, the whole cube takes 12 times to solve, and you just saw as we were going through it that it does, in fact, take 12 times to solve. So, that's basically how it works. It's the least common multiple of how many times it takes for each piece to get back to normal. That's basically how this works. And this can get crazy very quickly, because, like, this one, I don't remember if I showed this one at the beginning or not, right inverted, down inverted, which is just half of the right inverted, down inverted, right down one. It takes 15 times for a lot of the corners, 3 times for one of the other corners, and 7 times for all the edges, and the least common multiple of that is 105, and I tested this, and I may have tested it on camera, I'm not sure, but it does take 105 times. So it takes a crazy long time to finish it. But if that wasn't enough, if that wasn't crazy enough, here, right inverted, down inverted, left inverted, up inverted. Now you may think, how in the world did you come up with a pattern like that? That is a crazy pattern, and it is very complicated, and it makes absolutely no sense. Well, it does make sense, because if you go the front face, which is the face that's facing you, which can get kind of complicated and confusing, but fusing is another F word, and I am not fusing things together, especially not in metal, because that would be very hot on top of paper. But this algorithm, in fact, is spinning around the cube. Like that, you see. So that's how I came up with that one. And it takes 5 times for some of these edges, and it takes 7 times for others of these edges. It takes 3 times for a lot of the corners, and it takes 9 times for 3 of the corners. Yes. So that the least common multiple of 9, 7, 3, and 5 is 315. Check, dot, exclamation mark, question, that's not a question mark, question mark, dot, 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 and semicolon. Okay. I'm not sure what that was about. You could probably build a sentence with all that in it, except the circle, because I'm not sure how the circle would fit into the sentence. But you could have a sentence talking about that it's good, and then you put a period, and then the other guy says, "What did you say?" with an exclamation mark and a question mark in one, and you say, "I was talking about 2 sets of dot dot dots that were like," and then you put a semicolon, "a circle." There. That was a sentence with a circle, question mark, period, exclamation mark, 2, dot dot dot, semicolon, and question mark. So, yes, but that's besides the point. So, the point is about least common multiples and flipping the cube around center and getting all confused in the process, and Rubik's Cubes, and fun. And that's basically what it is. There's one other thing that I haven't actually done any extensive testing. I'm not sure if extensive testing would be the right word for even what I did here, because I just tried it with 1, 2, 3, 4, 5, 6, 7 algorithms, except I tried it with only 6 because I didn't actually do this one, and only 5 because I didn't complete this one. But it appears that I was watching for the corners to come back around to the same rotation, and I will demonstrate this with right inverted, down inverted, right down. So if you go 6 times, and I won't actually demonstrate that because I already did, if you go 6 times, it will go back to the same orientation in the same spot. But there's 3 different orientations that it can go in. And it appears that you can take the amount of times it takes to get back to the same spot, doesn't matter the orientation, and take that times 3 and it'll get back to the beginning. So like if I do it once, then it is not in the right spot. If I do it twice, then it is in the right spot, but flipped the wrong way. So you take twice of doing that, you multiply that by 3, that takes 6 times to get it back to normal. So it appears...
I'm sorry, but it appears that my iPod ran out of space while I was in the middle of recording the end of the video, which is very strange since it's the end of the video. So, anyways, as I was saying, yeah, it appears that you can always, the amount of times it takes for a corner to get back in the right orientation, in the right spot, it appears that you can take that and divide it by 3, and the corner will be back in the same spot, just in the wrong orientation, which means that if you're doing it and as soon as it gets back to the same spot, then you can take that and multiply it by 3, and it will get back into its original orientation too, if you follow me. And yeah, so that's basically that's basically it. So I hope you enjoyed this video about little stuff about Rubik's Cubes, how the algorithms work, and stuff like that. Because one thing that well, this is a little bit different topic. Not really a different topic, but one thing that I've found interesting is if you do the algorithm, when at the end, if you use the same solving method that I use, the algorithm at the end, to get the corners in the right place but not the right orientation, that algorithm is up. The non-technical definition is up, away from you, up inverted, away from you, up, towards you, up inverted, towards you. That is the technical, well, that's not technical, but yeah, so that algorithm seems to be very strange sometimes in how it selects the corners, and I've been trying to figure out how it works. So yeah, so if you're interested in that type of stuff too, then yeah, hopefully this video was helpful to you. And I'm all distracted because now I've got a mirror over there of all my movement, and it's like if I move to the away from me, it moves towards me, and if it's really confusing. But so I'm all distracted. But yes. So that's it for today, and hope you enjoyed this video. And this is Handy Andy signing off, and yeah, hope you enjoyed this video.